Hi class, today rather than meeting live, you're just going to watch this 8-3B warm-up. Don't forget, make sure you watch this all the way to the end because that will be your attendance for the day. Now to get started, we're just going to talk through some different things. Today we talked about graphing standard form, and a few days ago we talked about graphing vertex form. So we want to reflect on what is similar and what is different. So when we graph in vertex form and standard form, in both cases we need to find the vertex, and then we have to find a few other points. Okay, now number 2 says, how is it different? Vertex form, when you look at it, you can see the vertex, so you can see that point quickly and easily, but you have to calculate the rest. In standard form, however, you actually have to calculate the vertex like we did last class, and then after you calculate the vertex, you can actually see the y-intercept. Number 3 says, how can you visually check? That's been the same from the beginning. That's based on the A value. Remember, if A is positive, it should be opened up. If it's negative, it's opened down, and we should also be able to tell if it should be wider or more narrow. And the disadvantages and advantages, again, are just what's based on those similarities and differences. So we're going to spend more of our time talking about how we graph in standard form. The good news is this reviews everything we did last class as well. Because as soon as I'm given standard form, f of x equals negative x squared plus 6x plus 5, I am going to first find the axis of symmetry, the vertex, and y-intercept, which is what we did before. In order to find those, first I need to identify my A, B, and C. And remember, those come from the 3 different pieces. The A is the number attached to the x squared. This just has a negative in front, so I need to know that's a -1. The B is attached to the x, so in this case it's 6, and the C is the number on the end by itself, the constant, which is 5. Once we identify A, B, and C, we calculate our axis of symmetry, which is the negative B over 2A. That's that mini equation. So I know the mini equation, then I substitute. Negative B was 6 over 2 times my A was -1. Negative 6 over -2. Make sure you simplify the bottom first and then divide. So my axis of symmetry is the line x equals 3. Now my vertex has to be an ordered pair where 3 is the first component, or the x value, because remember, the axis of symmetry and vertex, those always match the first number. And so if I know the x value, I plug it back into the original equation to find my y value. Now again, just like with vertex form, when you want to calculate something like this, please just type the whole thing into your calculator. I'm going to show you once or twice how I would do it by hand, but again, in the end, I would just type it in, and I'll show you that at the end. So -9 plus 18 is 9 plus 5, which gives me 14. So the vertex is the point 3, 14. The axis of symmetry is x equals 3. And the y-intercept, as we reviewed, that's when x is 0. You could, in theory, figure it out every time, but you're going to waste your time. Because what we talked about is because x's are 0, it's always going to make those first 2 pieces go away. So your y-intercept is always whatever this last number is. So it's the 0.05. All right, so we can find those 3 things by using what we learned yesterday. So the extension was now we're going to graph it. Just like when we graphed vertex form, we're still going to take that vertex and put it in the middle of our table. Okay, so we make rows and we put it in the middle. We're still going to plot that vertex. So I go over 3, up 14. Now this is a little bit off my graph, so that's not ideal, but it's fine. We can still draw in our line of symmetry right through. Okay, so nothing has changed so far except for how we found our vertex. The only other minor change we're going to make from vertex form is we want to utilize the fact that we can find the y-intercept quickly and easily. So when we did vertex form, I said to fill in the rest of my table, I picked the next 2 x's to my right and the next 2 x's to the left. Problem is I know the point 0.05 is on my graph. So I want to use that. Now it happens to be 3 spots away, 3 x values away. So I'm going to put it here. But I want to utilize that for sure. Okay. Now once I plot it, if I'm graphing this by hand, if you're in Pearson, you can plot the vertex, plot the y-intercept, and that's enough. Because remember, Pearson only expects you to graph 2 points. Having said that, if I know that the point 0.05 is on the graph, I see that it's 1, 2, 3 spots away from the axis of symmetry. So if I go 3 spots to the right of the axis of symmetry, that point must also be on the graph because it's symmetric. And that's the 0.65. So if I'm drawing my table, which you'll be expected to do on the test, I can put that on there as well. So these 2 go hand in hand, which means I only have to calculate 1 more value. I chose to pick 1, which would go with 5 because that's 2 away. I could have picked 2 and 4 as well. I'm not sure why I picked 1 and 5, but when I went to do f of 1, I did negative 1 squared plus 6 times 1 plus 5. Probably picked it because it was a little bit easier math. Negative 1 plus 11 gave me 10. That means the point 110 is on the graph. So 110, which again, if I reflect that, it's 2 away from the line of symmetry. So that means 510 is also on the graph. So these two go hand in hand. So if anyone, you will be expected to show the table on the test, so make sure you understand that. But then I plot those, draw my parabola through, and remember to read Pearson carefully if it asks you to draw a line of symmetry. Okay, let's do another one. So again, the process is the same. I figure out my A is 2, my B is negative 8, okay, the whole number attached, and my C is negative 6. Make sure you keep those positives and negatives with it. This time I'm going to do x equals negative b over 2a, which is negative 8 over 2 times 2. A double negative is positive 8. Oftentimes we won't show the double negative, but since I'm teaching, I want you to see it. So I get x equals 2 as my axis of symmetry, which means my vertex is an ordered pair 2 comma something. So to figure out the something, I would plug the 2 into the original equation. Okay, so again, I would typically just type this into my calculator. When I typed all that in, and I'll show you that at the end, I got negative 14. So that's my vertex, which will for sure be in my table in the middle. And last but not least, I'm going to find my y-intercept. And this time I'm just going to say, I know if I plug in 0, I'm going to get that negative 6, that C value out. Okay, so when I go to my table, if 2 is the middle, if I work backwards, 1 is the next one and 0 is after that. So 0, negative 6 is within there. So I can count by ones in this one, 0, 1, 2, and then I'll pick 3 and 4 as my others. I plot my vertex to negative 14. Again, it's off the graph. That's not ideal. But then I also know 0, negative 6 is on there. Okay, so again, if this was Pearson, that would actually be enough. It'll reflect the rest for me. But doing it by hand, I need to understand what it does. So 0, negative 6 is 2 away from that line of symmetry, so I go 2 the other way. That means that 4, negative 6 is also a point. And then last but not least, I would plug in either 1 or 3. I chose 1. 2 times 1 squared minus 8 times 1 minus 6. Again, I would type it into my calculator, but just for order of operations, you'd have to square this first. So I get 2 minus 14, which is negative 12. So the point 1, negative 12 is on my graph. 1, negative 12 would be down here, which means that 3, negative 12 is also on my graph. Again, you could plug it in again, but that would be a waste of time if you don't need to. Now, one quick thing on Pearson. I actually don't think on this assignment they have you graph, but you still want to keep practicing it. We'll practice it more in class. Having said that, they ask you a bunch of questions like this, so you have to understand all the ideas of graphing. The only other thing it does ask you from time to time is what are the x-intercepts? You want to think about, it would be one where it wouldn't cross the x-axis. So I believe for all mine, I got no x-intercepts. So we will not expect you to find x-intercepts. So when it asks you that question on Pearson, just say there are no x-intercepts. And if it tells you you're wrong on that, just let me know. All right, so that's the first main thing you have to be able to do is graph standard form. And then the other thing is we now need to be able to convert back and forth. And the good news is it's just basic algebra, but you have to know your order of operations. This is vertex form, okay? So we have vertex form, and we want to end with standard form, which means we want it to be an f of x equals ax squared plus bx plus c, which means we want no parentheses, okay? And it's that understanding that makes me know what to do. I just have to do my order of operations to get rid of parentheses. The first thing I need to understand is that x plus 2 squared, we reviewed this a couple chapters, or last chapter, 2 chapters ago maybe. It's the same as x plus 2 times x plus 2. Okay, so we're just using our regular math knowledge to be able to do this. There's no new stuff, it's just order of operations. So x plus 2 times x plus 2, when we multiplied polynomials, we used the box. I put the x plus 2 on the outsides. I get x squared plus 2x plus 2x plus 4 Now, here's where we have to be careful. Don't forget when you're doing these steps to bring down the 3 and bring down the -8. What we're doing right now is we are multiplying this to get one polynomial instead of a binomial times a binomial. So when I did x plus 2 times x plus 2, I get x squared plus 2x plus 2x, which is plus 4x plus 4. Okay, so that's the first step. Multiply the binomial times the binomial. Now I still have parentheses, but it's one polynomial. Now I just use distribution. I distribute the 3 in front to all 3 pieces. 3x squared plus 12x plus 12. Again, don't forget to bring down the -8. And last but not least, we combine like terms. X equals 3x squared plus 12x plus 4. That is the same thing as the original in standard form. Meaning if I graphed both those in a graphing calculator, I would get the exact same thing. Okay, so we want to be able to convert back and forth. So let's do one more example of that. Okay, f of x equals -2 times x minus 5 squared plus 4. Again, the first thing we think about is that x minus 5 squared is x minus 5 times x minus 5 plus 4. Now, I often like to do the multiplying the binomial off to the side. So I'm going to put the x minus 5 times x minus 5 over here. I get x squared minus 5x minus 5x. A -5 times -5 is positive 25. The reason for that is I like to rewrite it right underneath. Remember, that -2 comes straight down. The plus 4 comes down. And I'm replacing x minus 5 times x minus 5 with what I get when I add these together. Okay, I combine like terms. I have x squared. I have a -5x minus 5x, which is -10x, plus a 25. Okay, once I get rid of the binomial times binomial, now I have to do my distribution. -2 times x squared is -2x squared. Negative times a negative is positive, so -2 times -10 is positive 20x, and a -2 times 25 is minus 50. Now remember, this plus 4 is not in the parentheses, so I just bring that down. I do not multiply the plus 4 by the -2 because it's not in the parentheses. And my last step is to make sure I combine like terms. So I have the -2x squared plus 20x, but now I have a -50 plus 4, which is -46. This is my final answer. Okay, so that's what you have to be able to do, graph in standard form and be able to convert from vertex form to standard form. What I need you to do now is to go to the 8.2b Pearson practice and try to get that completed. Tomorrow in class, I will be sure to answer questions that you have. We'll maybe look at this a little bit more to make sure you understand it, and then we'll move on. Okay, so go ahead and finish this and move on to your Pearson. Thanks.